Hello everyone, I am Dr. Mahendar, Associate Professor in the Department of Mathematics at B.V. Raj Institute of Technology, Narsapur. The today's lectures, I am going to cover one of the important topics, that is the limit of function of two variable. So before going to the class, so we should know what is mean by functions of several variables. So we are going to deal the limit of function of two variable, but we are aware of that limit of function of single variable. So let us will start with some examples. So for example, if you look at the function of several variables, what is mean by function of several variables? What is an example of function of two variable? Just look at the area of triangle. What is the area of triangle? For example, we have this one. Sorry, area of rectangle. Let us first will take it. What is the area of rectangle? The area of rectangle is length into breadth. So what is the area? L into B. Therefore, area is a function of two variable, L comma B. Suppose if you take the volume of the rectangular parallelepiped. What is the volume of the rectangular parallelepiped? It is depending on three parameters, that is length, breadth and height. So therefore, the volume of the rectangular parallelepiped L, B, H. Therefore, the volume is a function of three variable L comma B comma H. In the similar way, we can extend for the function of n variable. Suppose if Z is depending on n variables, we can write Z is a function of x1, x2 and so on xn. Means for every values of x1, x2, xn, the Z takes the finite value. Then we can say that Z is a function of n variable. So hope you understand what is mean by function of two variable, function of three variable, then how to extend function of three variable and function of n variable. Now, how to define or how to find the limit of function of two variable. So most of you aware of that, how to calculate limit of function of single variable. But in this curriculum, we have how to find the limit of function of two variable. For example, limit x tends to a, y tends to b, f of x comma y. How to compute this one? How to compute the limit of this one value? Okay, so for example, this is equal, let us say L, if and only if. So we have the definition, for every epsilon greater than 0, there is exists a delta greater than 0 such that modulus of f of x comma y minus L less than, for every 0 less than x minus a less than whole square plus y minus b whole square less than delta square for every point in x comma y in R. So that means for every epsilon greater than 0, there exists delta greater than 0 such that modulus of f of x comma y minus L less than epsilon for 0 less than x minus a whole square plus y minus b whole square less than del square for every point in, for all x comma y comma belongs to R, for every point in R. So this is the most of the students, they feel difficult to prove by epsilon definition. So I will give the easy way to compute the limit of the function of two variable at origin other than origin. So first we will define, then compute how to compute the limit of the function at origin. Okay, first we have the two problems. Generally we have, the most of the time they will ask how to find the limit at origin or limit other than origin. So we have the two types of problem. The type one is how to find the limit of x tends to 0, y tends to 0, f of x y. This is the type 1, and most of the types So the chances are coming for the type 1. The type 2 is limit other than origin at any point, limit x tends to a, y tends to b, f of x comma y. So first today's class will focus on type 1 problem, how to compute the limit at origin. So I will give the working rule to compute limit at origin. I will give the step by step procedure. The next class will move to the type 2 problem. Okay. So the working rule for computing this problem, limit x tends to 0, y tends to 0, f of x comma y. How to find the limit of this one? So first step 1, what we do? Step 1, first put x 0, then y 0. What we do step 1? First you take x 0, then after y 0. Let us say the value is f1. The answer is f1. Step 2, what we do? The reverse. First what we do? First put y 0, then x 0. Suppose this value, let us say f2. After step 1, step 2, let us observe the answers of step 1, step 2. Suppose if f1 not equal to f2, suppose if these two are not equal, then the limit does not exist. Even after computing the step 1, step 2, suppose if they are not equal, just you can conclude the limit does not exist. Suppose if f1 is equal to f2, then we will move to the step 3. The step 3 is put y is equal to mx. Put y is equal to mx. So along this you can compute, suppose along y is equal to mx, let us say the value is f3. Here again then compare the values of the step 1, step 3. Suppose if f1 equal to f2 not equal to f3, then again limit does not exist. Suppose if f1 equal to f2 equal to f3, then go for the step 3. Then go for the next step 4. Then go for the next step is step 4. The step 4 is what? So then put y is equal to along different path, y is equal to mx square. Y is equal to mx square. So let us, this answer is suppose f4. Suppose here if f1 equal to f2 equal to f3 not equal to f4, the step 1, step 2, step 3 answers are same, which is not equal to the answer obtained by step 4, then we can say that the limit does not exist. Suppose if all these 4 are equal, suppose f1 equal to f2 equal to f3 equal to f4. If all these are equal, we can say that therefore limit exists. Limit exists. The value of this, whatever the answer we have, that is the answer. So once again I quickly summarize how to compute the limit about the origin. So means exist means the value of the limits independent of the path. If all different paths, if you get the answer same, so that means limit exists. Suppose if you get different answer for different path, that means limit does not exist. So this is the flow chart for doing the problem limit at origin. So first what we do, step 1, first put x is equal to 0, then y 0, that answer let us say f1. Then go to the step 2, reverse, put y 0, then after x 0, let us say the answer is f2. After obtaining step 1, step 2, just see the answers. If f1 not equal to f2, then straight away what you have to say, by we can conclude by step 2 only, limit does not. Suppose f1, f2 is equal, then we will move to the Go to the step 3. What is the step 3? Along y is equal to mx, you have to compute. That answer is f3. Again, f1 is equal to f2, not equal to f3 does not exist. If equal, we will go for the step. So, what is means here? We are finding the values, we are approaching. So, this is the what we are finding, the limit at origin we are finding. So, along this path, along this path, along this path, linear path, along another path also we are different path we are evaluating. Along different path, the answer you get the same means the limit exists. Suppose if different value, if you get any path, that means the limit does not exist. Okay. So, this is the easiest procedure to compute the limit at origin. So, just we will do one problem. Okay. So, the problem is find the limit x tends to 0, y tends to 0, x square y. So, this is the problem. So, this is limited about origin. So, how to follow? So, whatever the steps I given, step 1, step 2, step 3 we can go. So, what is the step 1? The step 1 is what? First you take limit, put x0 then y0. So, what you have to write? Limit x tends to 0, y tends to 0. This is x square y by x to the power of 4 y square. So, first what I am taking? First I am taking the limit x tends to 0, I am taking first. Limit x tends to 0, x square y by x to the power of 4 y square. So, this is what? First what I am taking? First I am substituting x0, then after y0. Just substitute for x0, then after y, what you will get? This you will get. So, limit y tends to 0. Now, you can substitute x is equal to 0. Just you can compute this one by replacing x by 0. 0, 0 plus y square. Then finally, you can apply y tends to 0. Then you will get 0. Let us say this value is f1. Okay. Then step 2. What is the step 2? Do reverse. First you take y tends to 0, then after x tends to 0. What I am taking? Limit x tends to 0, limit y tends to 0, x square y by x to the power of 4 y square. So, first the inner one you can compute. First put y0. If y0, what will become that inner one, bracket 1? Put in place of y0, this is a 0, this is x to the power of 4, 0. Finally, you can substitute x0, will get 0. This is f2. Just go back and see the working rule. Suppose f1 not equal to f2, if you get, straight away what we have to say? The limit does not exist, but we got f1 is equal to f2. If you get f1 is equal to f2, then we can compute the limit other path also. Other path means y is equal to mx. Y is equal to mx also passing through the origin. Okay. So, let us step 3. Here f1 equal to f2. Then we will move to the step 3. The what is the step 3? So, along y is equal to mx. So, y is equal to mx also, it is a passing through the origin. So, along this path also you have to compute. Okay. So, put y is equal to mx, y is equal to mx. So, limit y is equal to mx and x tends to 0. Okay. So, this is x square y by x to the power of 4 y square. So, limit x tends to 0, put y is equal to mx, x square mx by x to the power of 4, thus m square x square. So, what will get here? Numerator we have the denominator x square is common. So, x square get cancelled. So, here get limit x tends to 0, this is mx by this is x square plus m square. By applying the limits, what you will get? X tends to 0 means this will get 0. So, this is f3. This is F3. Now look at F1 is equal to F2 is equal to F3 we got again. All three steps are equal. If steps are equal, then we do the next. We'll go to the next step. What is the next step? The step 4. So along another path, other linear, non-linear path you will take it, okay? Y is equal to mx square. So it is also passes through the origin. So y is equal to mx square. So what we will get? So limit x tends to 0, x square y by x to the power of 4 y square. Now replace y by mx square. So what will become this one? Limit x tends to 0, x square, this is mx square, x power 4, this is m square, x power 4. Just look at the numerator and denominator. Numerator also we have x power 4 term, denominator also x power, gets cancelled. What left? So limit x tends to 0, m by 1 plus m square. Now apply the limit, there is no x term, therefore the answer is what you will get? M by 1 plus m square. Suppose if you do y, for example, if you take y is equal to x square, so by substituting 1 you will get y is equal to x square. For different values of the path you will get different answer. So this is F4. Now look at this, will get different value along different m value. So here F1 equal to F2, F3 equal to F3, but not equal to F4. Why? Because this path y is equal to mx square, we got different answer. So is the path dependent. So it should be the path independent, limit exists. If all f1, f2, f3, f4 are equal, we can say that limit exists. But along this y is equal to mx square, we got the answer containing in terms of m. Whenever the depending on m, that means limit does not exist. Or if 4 answers are same, f1 is equal to f2 is equal to f3 is equal to f4, then we can say limit exists. Anyone not equal, we can say limit does not exist. Therefore, limit, the answer is what? Limit does not exist. Does not exist. So whenever the problem to compute the limited about origin means, first step put x0, then y0, then y0, then x0. If these two answers are not equal, we can straight away we can say limit does not exist. Suppose step 1, step 2 are same, we will go for step 3. How to compute step 3? Along y is equal to mx path. This answer, suppose f3, if f1 is equal to f2 not equal to f3, we can straight away we can say limit does not. If f1 is equal to f2 is equal to f3, we will go for the finally we can go y is equal to mx square. If this f1 is equal to f2 is equal to f3 not equal to f4, limit does not exist. If all are equal, we can say limit exists. Therefore, the limit does not exist because the value of the limit is depending on the path. So when we can say exists, the value of the limit is independent of the path, we can say the limit exists because it depending on the path. Y means if you take y is equal to mx square, y is equal to x square, y is equal to x square, y is equal to 3x square, you will get the different values. So therefore, this is the value of the limit is not independent of the path. Therefore, the limit does not exist. This is the flow chart or working rule to do the problem. Okay. So we'll do one more problem. The second problem is limit x tends to 0, y tends to 0, x cube, y cube. This is the problem. Again, it is also limit about origin. So just what is the procedure? We'll go step 1, step 2, step 3, step 4. If step 1 not equal to step 2, we can easily close it. If step 1 is equal to step 3, then we will go to the step 3. If all these are not equal to step 3, then we will go to the next. It does not exist. If equal, we go to the step 4. Okay, done. What is the step 1? The step 1 is what? The step 1 is what? First substitute x, then after y. So this is what I am doing. Limit y tends to 0, limit x tends to 0, x cube, y cube. This is according to step 1. First I am taking substituting x0. If x0, what you will get this one? Limit y tends to 0. If x is equal to 0, 0 plus y cube you will get, okay. Then finally substitute y0 is 0. So this is f1. Then what is the step 2? The step 2 first taking y is equal to 0, then after x is equal to 0. Limit x tends to 0, limit y tends to 0, x cube, y cube. So first substitute y is equal to 0, then will become limit x tends to 0, this is 0, x cube plus 0. So finally substitute x is 0, will get 0. This is f2. When we stop generally, if not equal, we can easily conclude. Equal, we will go to the next step, okay. Here f1 is equal to f2. f1 is equal to f2. Then we will go to the next step, okay. Third step. What is the third step? Along y is equal to mx. So this is the problem. At origin we are evaluating. So x0, y0, y0, x0 is over. Then you can compute the value along this path also, you will do it. Okay, look at that. Put y is equal to mx. Put y is equal to mx. So limit x tends to 0, x cube. In place of y I am writing mx. So this will become m cube x cube. M cube x cube. What is the answer now? Substituting x0, what you will get? 0 you will get. So again this is f3 answer. Okay. Then fourth one. If f1 is equal to f2 equal to f3, then we will go to the next step. Then we go to the next step. What is the next step? Put y is equal to mx square along this path. So this is what the along different truth, like, okay. So like we are coming. So limit x tends to 0, x cube. This is whole cube, m cube x power 6 by replacing y is equal to mx square. What you will get by replacing x? You will get 0. Now look at this answer. All 4 are equal. Therefore, f1 equal to f2 equal to f3 equal to f4. So therefore, limit exists. Therefore, if all are equal, therefore, hence limit exists. What is the value of the limit? What are the value obtained? The answer is what? So this is 0. So limit x tends to 0, y tends to 0, x cube plus y cube is equal to what? 0. So whenever if the limit about origin, you have to follow these 4 steps. Okay. So next we'll move to the how to find limit other than origin, means any point how to compute. For example, problems are like this. For example, limit x tends to a, y tends to b. So f of x comma y. How to find the limit of this type of function other than origin is given. So we will obtain in only 2 steps. Okay. What is the step 1 here? The step 1, this is the working rule to compute the limit other than origin is given. Okay. So first we have to do, first you can put x0 then y0. So x is equal to a, first what you put? X is equal to a, then y is equal to b. Let us take f1. Okay. The step 2, put y0 then x0, yb then xa. Let us say this is f2. If f1 not equal to f2, limit does not exist. F1 is equal to F2, limit exist. This means exist. We can conclude in only 2 steps. Okay, if other than origin is given. Okay, we will go to the one problem. Okay, we will quickly. For example, or compute or evaluate limit x tends to 1, y tends to 2, 3x square y, x square plus y square plus 1. So this is the problem. This is a looks different from the previous first one. It is the other than origin. About origin, how to compute? Other than origin. Other than origin, we will do only 2 steps. What is the step 1? First to take x tends to 1, then after y tends to 1. So first what we do, step 1. The step 1 is what? Limit y tends to 2, limit x tends to 1, 3x square y by x square plus y square plus 5. First you can compute the bracket one. What is the bracket internally? X tends to 1. So replace x by 1. So first replace y tends to 2. Now replacing x by 1. So this is 3 dot 1 dot y by 1 y square plus 5. Yes, by just substituting x is equal to 1, that is the 3y by 1 plus y square 5. So this is limit y tends to 2, 3y, 6 plus y square. Then finally substitute y is equal to 0, y tends to means what you will get? 3 times 2 by 6, 4. That is 6 by 10. This is 3 by 5. According to step 1, what you got? 3 by 5. So step 2 we can do. What is the step 2? So first what we do? First you take y tends to 2, then after x tends to 1. So that is limit x tends to 1, limit y tends to 2, 3x square y by x square plus y square plus 5. Yes. Then first substitute y is equal to 2 here. Limit x tends to 1, 3 x square, this is 2, x square 4 plus 5. So simplifying, what you will get? Limit, this is x tends to 1. So this is what? Numerator 6x square, x square plus 9, x square. Now finally what we do? Replace x by 1. 6 by 10 is equal to 3 by 5. So this is F1, this is F2. So F1 is equal to F2, therefore limit exists. Therefore limit exists. So what is the answer limit? The answer is 3 by 5. So just I quickly summarize how to find the limit of function of two variable. So just I categorize into 2. How to compute limit about origin, limit about other than origin. Limit about origin, I given 4 steps to compute: x0, then y0, then y0, then x0. If at all these two are equal, then we will go to the step 3, that is along put y is equal to mx. Suppose the answer is f3. If again f1 is equal to f2 is equal to f3, we will go to the f4. So whenever that not equal, we can say does not exist. If all are equal, we can say that exists. So we have covered 2 problems about origin. One exists, one not exists. So this just limit other than origin how to compute. So this is we'll do in the two steps only. Here this problem we got limit exist because first x tends to a, then after y tends to b, and y tends to b, then after x tends to a, we got the same answer. Therefore, limit exists. Suppose if we'll get different answer, we can say limit does not exist. So we'll give the practice problem. You can write it the practice problem or homework problem. Just practice it. First one, limit x tends to 0, y tends to 0, x minus y by x square plus y square. Okay. Second problem, limit x tends to 0, y tends to 0, x square y cube x square plus y square. Okay. So next one you can do it. Third one, limit x tends to 1, y tends to 1, 3x of y minus 2, 2y of x minus 2. These three problems you can practice. Okay. Two problems for limit about origin, one problem for limit other than origin. Okay. Once you are to familiarize with this limit concept, then we can define or we can check the continuity of the function of two variables. That we'll do in the next class. Thank you. I'm signing off.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.